So today let us do the rest of the questions in our section A. Okay, in our previous video we have done the first 10 questions. Now let us do the 11th one. Okay, so the question is, for the linear programming, the objective function is z is equal to 4x plus 3y and the feasible region determined by a set of constraints is shown in the graph. Okay, so now if you look at the graph, 4 corner points are given to you, that is P, O, R and Q. Of the following statements are true. Okay, so in order to do this, first of all, what we need to find, we need to find the maximum and minimum values. So we know how will we find the maximum and minimum values. If you see this this region, okay, is the feasible region and these are the 4 corner points. When we substitute the values of these corner points in our objective function, we will be getting the maximum and minimum values. Okay, so let us see. Okay, so first let us take the corner point O, which is 0, 0. Okay, now let us substitute it in the objective function. So 4 into 0 plus 3 into 0, which is equal to 0. Okay, so this is the first value. Now let us take P. Okay, the corner point P is 0, 14. Okay, so just substitute it. So 4 into 0 plus 3 into 14. Okay, so we will be getting 400. 3 4s are, we will be getting 120. Okay, now next corner point is R. R point is 40, 0. Okay, substitute it in the corner point. So 4 into 40 plus 3 into 0, which is equal to 4 into 4, which is 160. Okay, now the next corner point is Q. So Q, if you see, it is 30, 20. Okay, substitute it in the corner points. So we will be getting 4 into 30 plus 3 into 20. 4 3s are 120 plus 3 2s are 60. Okay, so 120 plus 60 is equal to 180. Okay, now let us just check our options and let us compare. Okay, now the option A is the maximum value of z is at R, which is 40, 0. Okay, so just say R 40, 0. When we substituted in the objective function, we got 160. But now, is it the maximum value? No. If you see, 0 is there, 120 is there, and 180 is also there. And we know that 180 is greater than 160. So, definitely, maximum value cannot be at R. Okay, so option A is wrong answer. Okay, now option B, if you see, maximum value of Z is at Q, that is 30, 20. Okay, so Q, we found the value is equal to 180 degree. Okay, and we find that 180 is the highest. So from here we can say that 180 is the maximum value. Okay, so the maximum value of the objective function occurs at 180. Okay, so we can say option B is correct answer. Okay, option B is the correct answer. Okay, if you want to check the option C also, if you see option C, the value of Z at R, that is 40, 0. Okay, at 40, 0 we got it is 160 is less than the value of, okay, 160 is less than the value of 0, 40. Okay, 0, 40 is 120. So if you see, we know this is definitely wrong. 160 is greater than 120. So since this is wrong, we can say option C is wrong. Now if you see option D, the value of Z at 30, 20. Okay, 30, 20, it is 180 is less than the value of 40, 0. Okay, 40, 0, it is 160. So we know 180 is greater, 160 is less. So definitely this also will be the wrong answer. Okay, so the correct option is option B. So I hope it is clear. Okay, so our next question is 12th one. Integral dx by x cube into 1 plus x raised to 4 the whole raised to 1 by 2. Okay, now if you see this integration question, there is a similar type of question in your miscellaneous exercise in your textbook. Okay, so here when you see this integration, okay, that is something raised to 1 by 2 and all. Okay, the bullet point or the concept that you should remember over here is take the highest power common. Okay, so here if you see inside this bracket x raised to 4, that is the highest power, isn't it? So we should take x raised to 4 common outside the bracket. Okay, so let us take the highest power x raised to 4 common. So we will be getting integral of dx by x cube into Okay, we are taking x raised to 4 common. So now when we take x raised to 4 common, the thing that you should remember is here this full thing is contained inside this half. Okay, so when we take x raised to 4 outside the bracket, the half should also be there. So into, I am taking x raised to 4 common and with this half. So into 1 by 2. Okay, don't forget to multiply it with this half. Okay, and whatever is inside the bracket, what will be x raised to 4 we took common. So in order to get 1 over here, we have to write it like this, isn't it? Because then only x raised to 4 will cancel. Okay, plus 1 you will be getting over here. Okay, now if you see, you can cancel this too, you can cancel this. So you will be getting integral of dx by x cube into x square into 1 by x raised to 4 plus 1. Okay, now if you see x raised to 3 into x square. So here this is of the form a raised to m into a raised to n is equal to a raised to m plus n. So we can directly add this and write it as x raised to 5, isn't it? Okay, we are applying the properties of exponents. Okay, so this was our first step, that is take the highest power common. Now what is our next step? Now we can do a substitution. That is, we can take this 1 by x raised to 4 plus 1 as t. Okay, so let us consider 1 by x raised to 4 plus 1 is equal to t. Okay, and we know if we are considering something to be equal to t, we have to differentiate it. Okay, so we will be getting dt is equal to. Okay, now if you are having a confusion over here, you can take it to the numerator side. Okay, that is x raised to minus 4 plus 1. Okay, so now you can differentiate. So we will be getting dt is equal to, this is of the form x raised to n. So we can write minus 4 x raised to minus 4 minus 1. Okay, plus differentiation of 1 is 0. Okay, so dt is equal to minus 4x raised to minus 5. Okay, see in your integration we are having a 1 by x raised to 5, isn't it? So whenever we do substitution, in order to eliminate a particular thing, we are doing the substitution, isn't it? So this x raised to minus 5, we can write it as 1 by x raised to 5, isn't it? So I can write dt is equal to minus 4 into 1 by x raised to 5. Okay, now this 1 by x raised to 5 we can keep on one side and take the other things to the other side. So if you take this minus 4 to this side, we will be getting minus dt by 4 is equal to 1 by x raised to 5. Okay, I hope till here it is clear. Now what can we do? Just substitute it back in your integral. That is 1 by x raised to 5 is equal to minus dt by 4. Okay, we can just substitute it over here. So we will be getting integral of, okay, here this minus 1 by 4, let us take it outside the integral. So here this 1 by x raised to 5, we can write it as dt, the whole divided by, then this 1 by x raised to 4 plus 1, we said that it is equal to t. Okay, so here there was a half also, isn't it? Okay, half is also there. So instead of this 1 by x raised to 4 plus 1, I can write over here t raised to 1 by 2. Okay, this as minus 1 by 4 integral of dt by t raised to half, we can write it as root of t, isn't it? Now if you see integral of 1 by root t, here we know what is integral of 1 by root x. We know that integral of 1 by root x is equal to 2 root x. Okay, so from here we can directly write minus 1 by 4 into integral of dt by root x is equal to 2 root t. Okay, so now we have done the integration. Now just substitute back the value of t. Okay, so from here I can write minus 1 by 4 into 2 into, okay, root of 1 by x raised to 4 plus 1. Okay, now here we can just cross multiply it. So minus, so before that just cancel this. So here we will be getting minus 1 by 2 into, okay, minus 1 by 2 into root of, cross multiply it. So 1 plus x raised to 4 by x raised to 4. Now if you see the numerator, let us leave it as it is. Now if you see root of x raised to 4, we know that x raised to 4 means the square root of x raised to 4 will be x square. Okay, that means we can take it outside. So we will be getting minus 1 by 2, and from here we will be getting x square into root of 1 plus x raised to 4. Okay, plus c. Okay, that is minus 1 by 2 x square into root of 1 plus x raised to 4 plus c. Okay, use your options. Option A, that is minus 1 by 2 x square into root of 1 plus x raised to 4 plus c is the correct answer. Okay, so I hope it is clear. Next question is integral of 0 to 2 pi cosec raised to 7x dx. Okay, now if you see this question, the first thing that should come to your mind is about the properties of integration. Okay, so this is a definite integration, and if you see limits are from 0 to 2 pi. Okay, so when you see this, the property that should come to your mind is integral of 0 to 2a f of x. Okay, we know that integral 0 to 2a f of x is equal to twice of integral 0 to a f of x if f of 2a minus x is equal to f of x, and 0 if f of 2a minus x is equal to minus of f of x. Okay, so first of all, in order to do this, we need to find f of 2a minus x. Okay, so here what is the function which is given to you? The function that is cosec raised to 7. So we can write that cosec raised to 7 of 2a minus x. So here integral 0 to 2a. So here in place of 2a we are having 2 pi minus of x. Okay, minus x. We can write. Now if you see over here, cosec raised to 7 of 2 pi. 2 pi in radian measures we know it is 360. So it is cosec raised to 7 of 360 minus theta. Okay, so now if you just draw your quadrants. Okay, we know all silver teacups, and we know that 360 minus theta lies in the fourth quadrant. Isn't it? 360 minus theta lies in the fourth quadrant, and here we are having cosec, and you know that cosec is the reciprocal of sine, isn't it? We know that 1 by sine theta is equal to what? Cosec theta. Okay, so we know that all silver teacups, and in the fourth quadrant only cos is positive. Okay, all the other trigonometric values are negative. So, and sine is only positive in the second quadrant. Okay, so in the fourth quadrant sine is negative, so its reciprocal cosec will also be negative. So we can say that cosec raised to 7 of 2 pi minus theta will be equal to minus of cosec raised to 7x, which is basically equal to minus of f of x. If you see, okay, so if you see, and we know, we said that if we are finding f of 2a minus x is equal to minus of f of x. The original function was cosec raised to 7x. So when we when we substituted in this, we found it equal to negative of the value. So according to the property, we can say that integral of 0 to 2 pi cosec raised to 7x dx, the value will be equal to 0. Okay, so if you see your options, option A. Okay, option A is the correct answer. Okay, so our next question is, what is the general solution of the differential equation e raised to y dash is equal to x? Okay, so now if you see this question over here, we are having the derivative in the power. Okay, so we know that we cannot have the derivative in its power. So the first bullet point that we should remember over here is we have to multiply the RHS and LHS with log. Okay, so let's do. So we will be getting log of e raised to y dash is equal to log x. Okay, we are multiplying log on both sides. Now if you remember, that is log of e is equal to what? It is equal to 1, isn't it? Log of e is equal to 1. Similarly, e raised to log x is equal to x. Okay, these are few identities that you should keep in your mind. Okay, so we know log of e is equal to 1. So from here directly we can write dy by dx is equal to what? Log x. Now if you see over here, in order to do the differential, okay, we have to find the general solution. Okay, so here we can do a variable separable method. Okay, so dy by dy, keep it over here, this dx bring to the other side. Okay, so we will be getting dy is equal to log x into dx. Okay, now we have separated the variable. Now what we need to do? Just integrate both the sides. Okay, so integration of dy is equal to simply y, and we know that integral of log x. Okay, this is something which you need to by heart and keep. Okay, integration of log x is equal to x log x minus x plus c. Okay, some of you might not know what is the integration of log x. Actually, we are finding this formula using our integration by parts. Okay, now if you for this such a simple MCQ question, if you do the integration by parts and all, it will be a very lengthy step. So just by heart it. That is integration of log x is equal to x log x minus x plus c. Okay, so we will be getting y is equal to x log x minus x plus c. Okay, option B is the right answer. Okay, looking at the graph itself, we can say that this is the graph of cos inverse x. Let us take any point over here. Okay, let me consider this point pi by 2. Okay, pi by 2 means 90. So that we know that cos of 90 degree is equal to 0 degree. Okay, here also if you see in the graph, the point pi by 2 lies alongside with 0 degree. Okay, similarly we can take one more example, that is cos 0 degree. We know that cos 0 is what? Cos 0 is 1. So here also if you see, the 0 is corresponding to the point 1. Okay, similarly you can take any number of examples and see, and you can just clarify it. And here if you see, this graph is we have drawn it along the y-axis. Okay, that means this is the graph of cos inverse x. Okay, it's equal to cos inverse x is the correct answer. Okay, 17th question is the function defined from real numbers to integers defined by f of x is equal to greatest integer function x is. Okay, now if you see, this is a question which is based on your continuity and differentiability. Now here this is a little tricky question. Now if you see over here in your options, they have said we have to continuity and differentiability at 2.5. Okay, so generally if we say, we know that the greatest integer function a discontinuous function and it is not differentiable. Okay, but here they have specified the values and they have to know. If we see the graph of this greatest integer function, the discontinuity is only happening at the real values. That is, if you see at this point 2 the function has become discontinuous, at the point 3 the function has become discontinuous. But if you see, if you are taking a decimal value, for example 2.5, now if you see from here to here, there is only a small changing happening. That is, here it is a straight line. If there is no discontinuity at that particular point, okay, and if you say generally, in general terms, the greatest integer function is discontinuous. Okay, we can understand it from the graph. But in the question they have specified it. X is equal to 2.5. Is it continuous or differentiable? So at that particular point, if you see, is there any discontinuity happening over here? No. So here one thing that you should remember is, whenever if they had said whether the function is continuous or differentiable at simply 2. Okay, if they had said simply 2, we could have said that the function is not continuous and not differentiable. But since they have said it as 2.5, they are specifying a value. It is a decimal value. So if you see 2.5 lies somewhere over here. So at this particular point, it is definitely continuous and differentiable. Okay, so if you see your option D, that is the given function is continuous as well as differentiable at x is equal to 2.5. So from here we can say option D is the correct answer. So the 18th question is, a student observes an open and uneven nest on the branch of a tree whose plane figure is parabolic shape given by x square is equal to 4y. Then the area of the region bounded by the parabola x square is equal to 4y and the line y is equal to 4. Okay, now this is a question based on your application of integration Now they see a honeybee comb. It is like a parabolic shape. Okay, and they have given the equation of the parabola as x square is equal to 4y. Okay, now seeing this x square is equal to 4y, the first thing that should come to your mind is this is an upward parabola, isn't it? X square is equal to 4ay. It is of that form. So first of all, we have to draw the figure. Okay, so when we draw the figure, x square is equal to 4y. This is an upward parabola, and it is and we need to find the area bounded between x square is equal to 4y and y is equal to 4. Okay, so y is equal to 4 means it will be somewhere out of somewhere here. Okay, which means we need to find this area. Okay, so this we are starting from origin and y is equal to 4 will be over here. Okay, so we need to find this area. Okay, so in order to do that, first of all let us find the area of this region and we can multiply it with 2, isn't it? Okay, now if you see over here, this area, it is bounded to the y-axis. So if the area is bounded to the y-axis, we need to write x is equal to, isn't it? So from here, we know that x square is equal to 4y. So from here, x is equal to what? Root of 4y. So we will be getting x is equal to 2 root y. Okay, if it is bounded to the y-axis, we have to find x. If it is bounded to the x-axis, we have to take y. Okay, so we can write integral. Okay, from where to where are we finding the area? We are finding it from 0 to 4. So integral of 0 to 4 to root y. Okay, this 2 we can take it outside the integration sign. Okay, now we can just simplify it. So twice integral 0 to 4, this we can write it as y raised to 1 by 2. Okay, now we can just solve this integration. So twice of 0 to 4. Okay, we know x raised to n is equal to x raised to n plus 1 by n plus 1. So we can write y raised to 1 by 2 plus 1 the whole divided by 1 by 2 plus 1. Okay, so we will be getting twice of integral from 0 to 4 is to 3 by 2 the whole divided by 3 by 2. Okay, so this 2 is present over here. Now first of all we know upper limit minus lower limit. So 4 raised to 3 by 2 the whole divided by upper limit minus of, okay, lower limit is what? 0. Okay, so definitely 0 divided by anything, that will just cancel off, so no need to write. Okay, so now we can just simplify it. So twice of, okay, now this 4 we can write it as 2 square into 3 by 2 the whole divided by 3 by 2. This 2 and this 2 cancels. So from here we will be getting twice of 2 cube, which is equal to 8 the whole divided by 3 by 2. Okay, now this 2 will go to the numerator. So we will be getting twice of 16 divided by 3. Okay, now 16 into 2 it is equal to, we will be getting 32 divided by 3. Okay, so that means that this much area, that is this much area is equal to 32 by 3. But in our question we need to find the area which is bounded by y is equal to 4. That means this area also we need to find. So what should we do? This area we found, in order to find this area also multiply it with 2. Okay, so we can write 2 into 32 by 3. Okay, so 32 into 2 is equal to what? Is equal to 64 divided by 3. Okay, option B is equal to 64 by 3 is the correct answer. Okay, so I hope it is clear. Okay, so the 19th and the 20th question, they are assertion reason type questions. Okay, so the first one, consider the function defined as f of x is equal to mod of x plus mod of x minus 1, then f of x is not differentiable at x is equal to 0 and x is equal to 1. Okay, now first of all see the assertion. Yes, the assertion is definitely a true statement. Okay, like whenever we see mod of something plus mod of something, okay, usually in most of the cases when such type of function comes, it will definitely be not differentiable. Okay, otherwise also if you draw the graph and see, of these two functions. Okay, there are more than 2 points. Okay, they are meeting it, so definitely they cannot be differentiable. Okay, and the reason they have given. Okay, isn't it? We find, how will we check whether the function is differentiable? We find the left hand derivative and we find the right hand derivative. The left hand derivative is equal to right hand derivative. We can say that it is differentiable. Okay, so that is what they have said over there. Okay, that is limit h tends to 0 minus is not equal to limit x tends to 0 plus. Okay, so definitely both assertion and reason, both of them are true. Okay, so for the 19th one, option A is the correct answer. Now if you see the 20th one, the function defined by f of x is equal to sec x is not defined in its domain. Okay, it is given from minus infinity to minus 1 unit 1 to infinity. Okay, and the reason is the line y is equal to 2 meets the graph of the function at more than 1 point. Okay, yes, we know f of x is equal to sec x. Sec is what? Sec is the reciprocal of cos, and we know that all the trigonometric functions are periodic. That means they will be repeating its value. Okay, if we take y is equal to 0.2, we know that sec of pi by 3 is equal to 2. Similarly, sec of 5 pi by 3 is also equal to 2. Okay, so basically in more than 1 point, the value is keeping on repeating. So from here we can say that since f of x is equal to sec x, okay, since the value is being repeated in more than 1 point, we can say that f of x is equal to sec x is not 1-to-1 function. So for the 20th one, both assertion and reason are true, so option A is the correct answer. Okay.